Good evening, everybody. Welcome to, guess what day is it? It's Sunday night rabbit hole. Normally we have this on what do you call it Clemmer's on here. Normally we have this on Saturday, but spend some time with my lady who, well, it was what it was. Anyway, love y'all. And we'll see. So we're going to talk about the Myanmar earthquake part 2, and also some significant events happening around the world. So stay tuned. You're going to learn something, or maybe you won't. If you find something of interest, go ahead and shoot us a line at jsldiscussion@gmail.com and let us know what you think. All right. Big hugs, y'all. And remember, pull my finger. Hey, there he is. Canuck and Clemmers on the channel tonight. Over there on twitch.tv/Josic Live, we have Timmy, Susan, Flutter Girl, Ramblin' Wreck, Eden, Gina, and Tadaya. Tada. Right. Anyway, I thought I go Tada. Maybe I didn't say it right. Apologize. If it's a different way of saying it, go ahead and let us know. And those people who do not want to be said, I'm just going to ignore your names. I see you. I'm just going to hang tight. And hopefully you come in and join us. So part D. Good evening, Clemmer. Good evening, Canuck. And we'll see where we go for tonight. We'll see, huh? We'll see. As I get the darn things are working. Yeah. Can you hear me now?
Yep.
All right.
Yep. Good.
All right. Nice and loud. All right. So we're all live. Good evening over there on Twitch. Thanks for being here. Okay, now you're gonna have to, it's you, buddy. That's okay. Yeah, I need to refill myself, but anyhow. But Canuck's gonna hit us with something real interesting. It's a pleasure to see Susan, Gina, Flutter Girl, Timmy, and Kitty Cat, and and I guess that's it for now. Eden's out there. Lake Girl just made it in. Nice. And Gina and Ta-da! Or Daya. Or is that Hedadiah was it from Bullfrog or something? Oh, it was Jedediah. Okay. Susan, I guess that's all the people that want to be talked. Yeah. Welcome out there. I'm sure 42 is probably listening too. And, I just stopped by for the night, she says. You're not here, are you? If so, I better get dressed. You know, kind of put on my dancing shoes. But anyway, I digress. Nice to see everybody there. No, heading north on North Cali. We have the whole West Coast. God, from I would say from Costa Rica down up to Alaska on watch right now. You got it lit up in there, buddy.
Yeah.
Better open a window. Or is it too cold? Oh, you turned the light out. All right. Keep the dog quiet.
Trying to.
Yeah. I don't blame you. He's got it's a mix, right?
No, it's a purebred Rottweiler puppy.
Yeah. She's rambunctious.
Yes, she is.
And anyway, Canuck, fill us in, buddy.
So I started dig it into the past of earthquakes in that specific area. Well,
Myanmar.
as I dug into all my stuff, I found out there was a big quake there in 1839, exact same spot.
Wow.
And it has a whole different name, and I'll have to explain why that is. So that's why it was harder to find.
Burma?
Because all these crazy name changes for places.
Yeah.
Interesting. So anyway, I'm going to put the wiki in there, and I'm basically going to read and explain it.
All right.
So I'll do that now.
So what we're going to do is we're going to get all the information out there, and then we'll discuss it after the fact.
Yeah.
I guess I'll start just the top part here. In 1839, Ava earthquake is also known as the Amarapura earthquake. Inwa earthquake was a disastrous seismic event that struck present-day central Myanmar on March 23rd. Wow, almost to the day. This earthquake was an estimated moment magnitude as high as 8.3, was on the largest in the county since 1762. What was assigned a maximum of an 11, wow, extreme on the modified Mercalli intensity scale, and was felt in Rangoon and Bamo. I don't know how far that is.
Yeah, and
damage
also
was
Bangkok.
enormous in Ava. What in Bangkok?
Also Bangkok, it says later.
Okay,
but
resulting
the
in
end
the
of
death of
this-
hundreds. So go ahead.
Yeah. Now I have to explain the history why this is called Ava.
Okay, good.
Okay, Ava is the capital of the ancient Upper Burma dynasty. So it's named after the name of the dynasty, Ava dynasty, because Burma had dynasties just like China. So Ava was the original capital of the Burmese dynasty. Now, where Ava is today, they call it Inwa, and it's on the southern outskirts of Mandalay, and it's where the big bridges cross the Irrawaddy River, one of which is flattened now from the latest earthquake. So that's where Ava was. And in 1839, it was controlled by the British. But that's what they called the quake. So this quake is basically in the exact same place as the one we just had. So it's crazy stuff. And it was on March 23rd.
It's just a couple miles off, right?
Yeah, just a little bit below Mandalay.
Okay.
But as it gets into this, it explains more stuff. So I'm just going to read more, but it explains.
As you're reading, I'm going to go ahead and try to get the other people on the other channels to be able to see what we're seeing here. But first, I want to open up GE. And so basically what we did over there on Twitch is we use the channel to kind of explain the history behind Myanmar. And I'm going to put this link, share my screen with our boys and girls and women and men over on the other channels. Well, so looking at Myanmar right here on Google Earth, the main cities, let me see, file, view. No. I want to see it all, boy. Come on.
Yeah.
View, show grid lines.
The three largest cities are all on this fault.
Okay, we see everything already. So,
yeah. So Mandalay, Naypyidaw, however they say it, which is the capital now.
Okay, here's Mandalay right here.
And then Yangon, which is also Rangoon. The British called it Rangoon.
Well, it's down in the south. Okay.
Yeah.
So that's kind of what I want to do. I want to show people the breadth of this earthquake as you're discussing it. So
yeah.
I want to get the what do you call it? coordinates. God bless America. Go back to 7 days. Now go back on the largest. There we go. 7.7. Burma had a 6.7. And I don't know what this Riverton is. What the hell is that? Oh, dude, did you know about that one? 324.
Yeah, the New Zealand one.
Yeah. Oh, yeah. Okay.
I already looked it up. So
Yeah, I'm like, what happened to her? Okay, so back to here.
because New Zealand gets big ones when Burma does as well.
Okay, so I wanted to save us
Pretty interesting.
an Untitled project. All right.
Is it like the same pattern, Canuck? Does it usually?
Yeah,
New
you're going to
Zealand
see
get
you're going to see when we go into this, and
Right.
it has a tie into 1838 Sandman too. So it's
Okay.
good stuff.
Okay, so right here's the earthquake. Okay, and Rangoon or Yangon or Yangoon is down here. All right.
Yeah, bottom.
So this earthquake, let me do a measure here. 347 miles away. Okay. People felt it, right? I don't know if where else did they feel it there, Canuck?
Well, the capital, which is in between Mandalay and Yangon, Rangoon.
Ninipedia or whatever.
Yeah, that's the capital right now. The military government, that's their capital.
Okay.
Yeah. Under the British, it was Rangoon, Yangon, but
okay.
The military government has the capital down in Naypyidaw.
Okay, Naypyidaw. Okay,
but every one of these three major cities are all along the Sagang, or however they say it.
Yeah, the same fault line which we talked about before.
And I like how they explain it in with this wiki. It's way more simple.
Go ahead. You run.
Yeah, so I'm going to read that part. Myanmar is wedged between four tectonic plates: the Indian, Eurasian, Sunda, and Burma plates that interact due to active geological processes. Along the west coast of the Coco Islands, off the Rakhine coast, and into Bangladesh is a highly oblique convergent boundary known as the Sunda megathrust. So this relates back to 2004, basically. This large fault marks the boundary between the India and Burma plates. The megathrust emerges from the seafloor in Bangladesh, where it runs parallel to the east of the Chin Hills. This boundary continues to north of Burma, Myanmar, where it ends in the eastern Himalayas. The Sagang Fault is a mostly continental transform fault that runs through Burma and connects the Andaman Spreading Center to the collision zone in the north. It accommodates motion between the Burma and Sunda plates as they slide past each other at a rate of 18 to 49 millimeters a year, depending on which segment you're on or you're talking about. The fault runs the entire length of the country for over 1,200 kilometers and continues its trace into the Andaman Sea. The Sagang Fault is Burma's largest and most active source of seismic threat, running through or close to major cities like Yangon, Naypyidaw, and Mandalay. Several damaging earthquakes have occurred on this fault in historical times. In 1946, the 180-kilometer, 110-mile-long Sagang segment produced two major earthquakes, but there are no records of its impact. Well, that's not true, because there's a whole bunch of studies on it. 10 years later, in 1956, which we'll talk about that one too, a magnitude 7.1 earthquake struck close to the city of Mandalay, re-rupturing the 1839 rupture zone for about 60 kilometers. Meanwhile, the 260-kilometer, 160-mile-long Mektila segment has not experienced any major earthquake since 1839 and is considered a seismic gap, but it's not anymore. Now they say it was both the Segang segment and Mektila segments that ruptured this time in the quake. So now I'm going to read about what the stuff they found out about this earthquake that was back in 1839. The Mektila and Segang segment of the fault ruptured during this earthquake for a length of 400 kilometers, 250 miles, corresponding to a magnitude 8.1 to 8.3 earthquake. Although little research has been conducted to provide further constraints, which is also not true, because there's been new studies on it in 2022 and 2024, which we'll actually look at. It has cool maps. On the basis for its overall lack of seismic activity, the Mektila segment is believed to have ruptured during the earthquake. This segment runs from Ne Piatau to Mandalay, a length of 260 kilometers. Remote sensing and field observations revealed a maximum displacement of 5 to 7 meters, 16 to 23 feet along the trace of the 1839 rupture.
Say that again.
Okay. The displacement of 5 to 7 meters, 16 to 23 feet along the trace of the 1839 rupture just outside Mandalay. This would place the magnitude at 7.48 plus and generate a 300-kilometer, 190-mile rupture. Now, the latest on the current quake that we just had, they said the displacement is 6 meters, around 6 meters, a little bit above 21 feet.
Okay, so what happened in Ridgecrest was a 15 or 16 foot rip. What happened in the other one prior to it, it was a near 15 foot rip, and the 7.3 was a 17 foot rip. So put it in perspective. You see each point magnitude higher is a few further feet of a visible rip on a rupture on a surface. So if they're saying the rupture was 21 feet from 17, just go, 7.1 to 7.3 is basically what, was it 15 to 17, right? Or 13 to 17?
Yeah, so the west side of the fault moved north.
Yeah. So this side is moving, this side's moving north, and to 21 feet, that's damn near 8. Because if you go 7.7 or 7.5, you're going to, 18 feet, 19 feet, 7.7, just like what we just had. Probably 19 feet to 22 feet. I don't know what our rip was on this one. The current
21
quake.
feet, they say right now. That's
okay, so that's a 7.7. I don't have it as high as that. I think what I quoted it as 7.4 to 7.5, maybe even 7.3. I'll let you know that in a minute. But interesting.
Yeah, I'm going to read the next paragraph.
So the displacement means this side moved north and this side moved south along the rift. And if this is moving south, you know what's happening. All this is moving too. Right? All 2,700 feet or 2,700 miles of this whole plate boundary. So if I do it here from Krakatoa, right? And I just run the muck all the way through Banda Aceh, which we had quakes in Banda Aceh. And I'm running up here through Rangoon. up into here, 2,500 miles, right? So along that 2,500 miles, we have things happening. Banda Aceh, we have northern Sumatra that's been bouncing, right? Just by looking at USGS, I don't know if they have anything showing it, but going over here, there we go. We do have a quake on Banda Aceh right here, a 5.1. That happened yesterday, right? After the seventh quake.
It's going to respond to it because it's all part of it.
Right. And, we had a 6, I think, up there in Burma as well, 4.3 and then 5.1 up in Burma or Mandalay, right? So interesting. And then even down here in Indonesia, and I talked about this morning in the report. I don't normally do Sunday reports, but because of, circumstances, I went ahead and did it because a Tonga popped all the way over, follow the plate boundaries. Let me share this tab instead. From here down to Banda Aceh, down to over here to Indonesia, right? Down here in the Flores Sea, right? And then up and over and down and under to the big quake that happened 7.0 today in Tonga. And Tonga's acting normal with several big quakes in Tonga today. So let me see. Got at least 10 quakes, maybe 9. This Fiji Islands is 339 depth. But a couple of big ones for sure. That's 17 kilometers depth. That's a 6.2. And then a 7.0, which was 29 kilometers in depth. Very, very dangerous earthquakes happening in the sea. But up here, and the only thing we have in China moving north is a 4.3, as the 4.3 down here. So back and forth. We had a quake up here. I just said down here, hey, watch out Japan. And sure enough, Japan popped this morning, 4.5. So we have 4.5 power moving away from the Burma quake. We have from the 7.0, we haven't seen much of this responding because waves emanate out in all directions from the earthquake. Pressure moves out. However, if you drew a line from here to here, that's a liniment that we know about, very well know about. And we're watching something, on the north side of Iceland. However, on the south side, Rick James bopped yesterday as well. And so we will be watching. Also, if you follow that straight down, we do have the Sandwich Islands banging away, but nothing on Easter Island. Reported by USGS. Now, USGS doesn't report everything. Just be aware of that. And also, because of this, the EPR in the way, that energy could splice, move south and move north. And we've seen a series of quakes along the Texas liniment, full Blanco. We have here California. We have here Arizona. We have here Texas. Get Puerto Rico. And we had another quake yesterday out here in South Africa. We had a quake up here on the Mid-Atlantic Ridge yesterday. And we also had one on the Indian Ocean yesterday. So, hey, things are happening.
So I want to read the last 2 paragraphs in this because it's important.
Okay, let's go.
2024 study.
Okay, go ahead.
Researchers at National Taiwan University combined LIDAR and macro-seismic data from historic accounts to estimate its magnitude at magnitude 7.9 and rupture length to be 285 to 325 kilometers, 177 to 202 miles. The 1839 earthquake ruptured 2 segments, the Mektila segment in the south and the Sagang segment in the north. They estimated 5.5 meters, 18 feet of displacement on the Sagang segment, while slip on the Metelis segment was around 3.8 meters, 12 feet. The felt area, based on the modified Mercalli intensity, was larger than the 1912 Maymayo earthquake, magnitude 7.7, which I think was, I don't remember if that one was in the north or in the south.
It's in the central.
Or was that one central too?
Mm-hmm.
Maymayo.
It struck on May 23rd as well. So 23 seems coming up. Calculated to be an 8. Go ahead. You can continue.
Yeah, and they said similar in area to the 2002 Denali earthquake. And this is important for when we talk about the 2024 study because they compare the fault to other ones around the world. The maximum assigned modified Mercalli intensity was extreme, so 11. So if that's the case, they said this one was 9. So
all right, the 2002 Denali quake was a 7.9.
Yeah.
Wow.
So now back to this one. The main shock was preceded by a large foreshock in 1838, which also damaged the capital. Now, I couldn't find out what the date was for that, but 1838 is the same year as we had the first big San Fran quake that we know about. So I thought that was interesting.
All right, let's see.
Yeah.
All right. Gia, we'll look up Gia. Was 1912? No.
No.
1838. All right, go ahead.
We're going to look at 1838, 1839 after I finish reading this last one.
Okay.
This last paragraph. Great damage was reported in Inwa, so severe that the former capital was moved to nearby Amorapura. In Mingan, a stupa sustained serious damage as a result of shaking. British officials in Myanmar recorded catastrophic damage and liquefaction in Mandalay and the surrounding area.
Mm-hmm.
Many pagodas collapsed during the event. Chasms and fissures more than 10 feet, 3 meters wide were seen in Amorapura, and nearly every brick building was reduced to rubble. Some villages were swallowed up as a result of liquefaction. By a contemporary British estimate, about 300 to 400 people died, but the population was way less back then. I'll talk about it later. The shock also reversed the flow of the Irrawaddy River, where the currents became violent and overflowed its banks. It was felt for thousands of miles away from the epicenter, as far as Dhaka, Kolkata, and Bangkok. So, same as what happened. Same thing as what we just had. So I thought that was super interesting.
Yes.
Yeah. Of course, everything was way smaller in 1839. Because I looked up the population, which I'll say that right now. In 1850, the population of Mandalay was 167,000. The estimate today in 2025 is 1.6 million. Half are Chinese, half are Burmese.
That's like 10 times the amount it was back in when the first one happened.
So like 100 times.
Yeah.
Not 10 times, 100.
Yeah, it'd be 10 because 167 to 1.6.
Wow, it's
million.
Amazing. Add 1 0.
Yeah, so it's like crazy.
So, but
and I have to explain before we're going to look at Gia first because I want to see what.
Yeah. I just looked at Gia. Pretty interesting.
Yeah. Which is Gia is the Global Historical Earthquake Archive, which basically has every big quake that they know about from the year 1000 up to 1900. So
all right. So I'm going to start with 1838. All right. I want to show this quake to begin with. This quake here, guess where it is? Yeah, New Zealand.
Yeah.
All right. It's New
Riverton.
Zealand.
It's actually, I think, northern or something.
Utapu. Yep. Northern Island, New Zealand. Right?
Yeah.
Right. And we just had Tonga today, remember? Not too far away, but still a little distance.
Yeah. We had 6 point whatever at the bottom of the South Island of New Zealand.
And look at this. The next one is a Pakistani quake. Right?
Yeah.
And that's you can see right here, Pakistan, Iran border. Right? And then the next one is right up here. And it is basically in Europe, not Ukraine, but it's right here. Romania.
Yeah.
Okay. Look at that straight. Now look at that straight line. Bing, bing, bing. Right? So that's the 3 quakes in 38. The fourth 38 quake is in the US.
Yeah. That's the San Fran one that we talked.
Correct.
When we did San Fran.
Just south of San Francisco, right? Just south on the San Andreas. Right? Big quake. Big. 7.4.
And look at the ones in 1839.
Yeah. Right? See, another San Miguel, which is down in San Salvador.
Yeah.
Right? Central America. Right? Now, we've seen earthquakes already down here. Right? Just a couple of days ago. And also, there's a couple of volcanoes that are activated in this region, just a couple of days ago. 39. All right, I'm going to unlock all 33, all 38s. 39. The first one, Martinique. What's been happening lately in the Caribbean? Just north of this, we saw some really big quakes happening. Very unusual. Like, why are they happening? Then we go, the next one, 39. Well, shoot howdy. That's in Salvador again. I wonder.
It's magic.
And then in 39, Miramar. 323. And look, straight line. Ding, ding, ding. Just off with his little hair, but still relatively straight line.
It would be within the guitar string wobble as you pluck it, basically.
Yes. Yep. And then we have another 39, Kushiro, which is up in Hokkaido. We just had an earthquake in Hokkaido today.
It's magic.
It's not like in the same exact spot, but what we're saying is,
yeah, and you have to remember the quakes that are in this GIA list are big.
Yeah, so these are all the large quakes, everybody. Now this one here is a 7.3. All right.
Yeah.
But again, what I'm trying to get at is we're pinging a similar pattern that persists. And then also in 39, bang. Martinique again. Right?
Yeah.
I mean, seriously. In August, bam, out here. The other one's up here. Again, it's like
it's basically Caribbean, North American plate boundary. Same
correct.
Stuff that's been going on recently.
And 39, the last one is a Baikal, Russia.
Yep. Which there was a quake right up there by Baikal the other day too.
Yes, there was. the other quake was just right over here, not too far, but along that old plate boundary. So it's like, all right, what's the repetitive deal here? What are we seeing?
Because it's how it works. Now,
Right. And I believe it to be electromagnetic pulses that have something in our core or in our mantle or in some sort of criteria that it continues,
and
whether
there
it be
was
a scar or a, go ahead.
There was a large quake in this same area in 1620. But I couldn't find much info on that. I'd have to dig more. But we can look back on GIA to see what was happening in 1620.
Well, get this.
Well, yeah, if the
In-
info
in
was
18
there, it'd probably be scary on how much the same pattern would be repeating time after time.
Right.
Well, it looks to me like these segments that are around Mandalay go off about every 200 years, based on what I've found so far.
Yeah. And in 1840,
a near
1840, you just keep continuing down that line past Jakarta on Java, and you have another big quake in the middle of Java.
What's the magnitude of that, bud?
7. And then it follows around over here to just south of Halmahera, North Maluku, right? They'll call that Indonesia. It's another 7, right? And we can continue.
You can reconstruct all these things if you can find the data.
Right.
But once I see it 4, 5, 6 times.
Correct. It's like you can't argue it. Right. Now in 1840, again, back over to Central America. Right? Just south of Salvador in Nicaragua.
Like I imagine the Antarctic plate boundary was going nuts, which we don't have data on back that far. And I imagine the Mid-Atlantic Ridge was acting up too. But back then we didn't have data on it.
Right. So in these 2 years, 1838 to 1840, a series of quakes happened repetitively in a cycle. And the last one in 1840 happened in Turkey, eastern Turkey, another 7. So, and eastern Turkey's been banging off, pretty good here.
So basically the 2024 study that we're going to look at next basically said that they should have been looking for a big quake in this exact spot based upon what the last 45 years of quake data says, and also this previous quake in 1839. Because they're referring, before they did the study in 2024, it says they did the historical quakes in Burma all over again in their database. And they actually used any quake above 3.5 since 1980 in Myanmar, Burma, to figure out what segment should go off next, which that's what we're going to look at next. Because it kind of brings all this stuff together into like current.
Where do you want to go, bud?
I'm going to give you the link to the 2024 study because it has cool maps and shows where all the quakes are and everything for the last 40 years.
Mm-hmm. Cool.
So I got to copy it here. It's got a nice big map that's very simple and high definition. You can see what they're talking about. So there, I copied it. Let's try her again. Get her in there. So there, it's in there now.
I got it.
The big
abstract. Map. All right, let me read the abstract. Precursory seismic quiescence of major earthquakes along the Sagang fault zone, central Myanmar, application of pattern informatics technique. So they're looking for patterns, okay? In this study, the precursory seismic activity before major earthquake was investigated by using the pattern informatics, or PI, algorithms along with the Sagaing fault zone, central Myanmar. After improving earthquake catalog, the completeness of seismicity data with a magnitude of 3.6 reported during 1980 to 2020 was used in retrospective testing to find suitable parameters for the PI algorithm. According to the retrospective test, with 6 cases of different forecast period times relating to greater than 5 magnitude earthquakes, including verification using relative operational characteristics, or ROC diagram, the characteristic parameters of both time intervals, change time and forecast time window equals 10 years, and the target forecast earthquake magnitude greater than 5 are suitable parameters for the PI investigation along the Sagaing fault zone. Therefore, the parameters were applied with most up-to-date seismic data set to evaluate the prospective areas of upcoming major earthquakes. The result revealed that the Mayakina and the vicinity of Naypyidaw Da might be at risk of major earthquake in the future. Therefore, effective earthquake mitigation plans should be urgently arranged. Now get this. This was written in 24.
August.
Right? Yeah. Okay. Written in 24. And it's talking about patterns, persistent patterns over time. Okay.
Yeah,
That's what we're looking at.
Yeah. And this is 1980 to 2024.
Right. And in addition, what they're looking at, everybody help Timmy get a haircut. What they're looking at is 2s and 3s and 4s and 5s, and then greater than 5s, to say the 2s, 3s, or the 3s and 4s are forecasting things greater than 5s. Once you start seeing all the big quakes, then you start seeing the everyday stuff start to happen. And it's kind of like your brain has to extrapolate out a little bit and just allow the information to kind of permeate, and it sits there. And as it ferments in your brain, and in just kind of like in the ether, you start to see when the 3s and the 4s start to speak to you, not in a word or anything, but you start to see the pattern over the entire planet. And it's like, oh gosh, I've seen that before. Because if you study these things enough, and these people did 6 different cases, not unlike what we do here. That's the incredible. They're using an algorithm, a perimeter, suitable parameters for the PI algorithm. They're pattern informatics. It's what we're doing, but we're using
it's almost like having deja vu.
Right? It's like, it's almost saying that there's nothing out of the ordinary that is happening every day, because it's already in a pattern. It's already going to happen. It's like something tipped the TikTok, what's that pendulum, right? Tick, 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 on everything, right? Something did something, and the earth is responding to that. And the electromagnetic pulses that I've talked about, the patterns that this thing's talking about, and the patterns that Canuck's talking about, all these things together, and the solar activity, all of this stuff, incredibly. You have to take it in. Yeah, kind of just got to have to let it sit out there. If you grab onto one thing only, you're not going to get it. But you've got to let it sit in the ether. Then just allow it to kind of guide you. Then you'll start to see. And no, you're not forecasting. But what you're doing is you're seeing a pattern. And you can say, well, okay, this is an area of interest. It could happen somewhere in this area. We're looking for something a 5 or above a 5. And sometimes you get it. And sometimes it doesn't happen. It's like, well, what happened? Well, maybe we got out of sequence. There's, like they did theirs from 1980 to 2020, right? 40 years. They looked at 6 things over 40 years, watching for the similar patterns to persist.
And we're going to talk about each one of these.
Okay.
Like they just have the year on there, but I'm going to explain it. Like we can look into the same years because you're going to find a lot of crazy stuff. Now, the one I want to do first is the one down at the bottom next to the Andaman. See? 6.0, 1991.
Okay, I see it down there.
Okay, so now go up to near the top. 1991 was a 7, a little bit above Mandalay.
Mm-hmm.
So in that instance, it looks like it went
Yangon. Yangon
7
was a
at the
6, and then a 7 happened up here in Mandalay, just north of Mandalay. All right. In 1991.
Now, I believe that 1991 quake, because I looked it up before, was January 5th. Well, I looked through the year 1991, and I'm just going to give you the highlights for the West Coast.
Mm-hmm.
Blanco fracture zone off coast Oregon down to North Cali had multiple 6s and 7s in 91. Leading into all the North California quakes in 1992. So it's crazy stuff when I started looking at
most definitely.
Well, we had the Burmese quake that we just had Mandalay, right?
Yeah. I
quickly looked up. I'm sharing a tab because I watched this thing. Watch out for this. Sure enough, this is the quake. Nickerbar 5.1. Now you were talking about a 6 being right down here on that same fault system. That blew up this down up here. And now this one right here, it's along that same system, blew up this up here. Right? That quake happened on 3/23 this year. The 5.1. I go, oh my gosh. Andaman Sea just went off pretty good. The reason I say Andaman Sea, why? Because if I go back to share this tab, if I go back to here, right? Here's Banda Aceh. Here's the 2012 8.2 right there. And I bet you if we looked around, we could probably see a precursor that would lit that off.
2012 quake that's at the top there, close to Mandalay.
Mm-hmm.
That one was early November, just like a week after Haida Gwaii had the 7.8.
1994?
No, 2012. I didn't know about the 1994.
Oh, the 6.8.
Yeah.
That you have here.
Yeah.
All right. 6.8 happened here. And then
was around the same time as the Haida Gwaii 7.8.
Okay. Now preface that with the knowledge for those who didn't hear part 1 of this video. Part 1, we're pretty keying in to over here on the west coast of the U.S. And here's Haida Gwaii. Here's Alaska, right? We're keying in on from the whole west coast, basically. We think something is coming in greater than a 5 on the west coast of the U.S. or Canada or even Mexico for that matter. Yeah. Mexico is showing a lot of signs of a lot of movement from Chiapas all the way up to the Gulf. And we see a lot of earthquakes in California right now. And just today.
Yeah, there's a couple other quakes on this map that I didn't know about because it's including all.
I'll get right to that, but let me share this tab real quick. This is why. Look at the interesting. This is just today. Series of earthquakes that come right out of Nevada all the way through Los Angeles, right? Or just into Los Angeles.
my question would be is what is the tremor showing up in the Pacific Northwest right
Okay,
now?
we can check that in just a sec. Texas liniment activated. Really, I mean, it's clear lines. Something's going on. It's being pushed, and however you can see which right direction, you got to kind of look at that. So let's go ahead and real quick and look at the tremors. These same of the tremors are going to be on in the morning. And get this. The Seattle area, vibrating.
Yeah, I already knew that.
Yeah, I know you did.
Because I watch it on and other things. So,
Yeah.
but
Also,
so it's interesting.
Also down up here in Northern Cal. Also right here. That's off the Blanco, Texas. This is area. Trinity, just north of Trinity National Forest, Klamath. Okay. We're going to go back to.
How about yesterday?
Back one. No tremors reported. So back to the article.
Okay, back to the same map again.
Okay,
See,
gotcha.
It has a 6.4 in 1994. Now, I just saw that today. I never.
There's one up here, 6.1, 94, 6.4, 94.
Now, what's interesting about that, that's the same year as Northridge.
Northridge, yes.
But I don't know what exact dates those two quakes were. I never looked them up because I just saw this map today.
Well, let's look here. No, 94, right?
I can't remember the San Simeon date. Or the Northridge was January, I think.
So it's probably a good chance them happened after the Northridge quake then.
Yeah.
In
But it
94.
kind of goes back and forth by all this stuff that I'm seeing. It has weird
let's see
parallels
here,
when it
94.
goes off.
Kind of like a little teeter-tottering maybe on the dates.
Yeah, it's like the west coast of North America seems to respond when Burma has a big quake for some reason.
Right.
6.4. Burma quake. You got Northridge happened on January 17. My wife and I were just barely together. List of earthquakes in 24. All right, let's just go ahead and do this for fun. Share this tab instead. All right, we're looking up the list of quakes in in 1994. All right, I'm looking for Indonesia. Java had a set. Oh my God.
Once you start digging, it gets interesting.
Yeah, you start to see things over and over and over. Okay. Remember, this is the 1994 quake we're looking at on this article right here at 6.4, right? Also a 6.1 in Burma. Okay. So looking back, Myanmar 6.1, right? That was in January, right? Is that January? January.
So same
Look at that.
Same month as Northridge.
I get this. Not just Northridge, Pennsylvania. 2 quakes, a 4.2 and a 4.6.
Yeah.
Peru, Puno, Peru, 6.9. Papua, Indonesia, 6. And Shanghai, China, 5.7. Okay. Then Northridge, bam. Right? Also Northridge, 5.6, bam. Then Papua again, 6.8. Indonesia, Lampung. That's I think Timor region, I think. Halmahera, 7.0. Northern Mid-Atlantic Ridge, 6.3. We've already had that. And then an aftershock of 5.1. So Northridge, 5.1, 5.6, 6.7. Pretty damn good quakes, all in January. India had a quake of 5. Wyoming popped with a 5.8 in February.
Wow.
Western Uganda, that's Africa, I believe. Vanuatu, 6.9. What the hell? South Pacific Ocean 6.7. Kagoshima 5.4. Vanuatu 7.0. Lampung again 6.9. That's the Lewa earthquake 94. And that's that's on Sumatra, southern Sumatra. That correlates right in well with what we're talking about.
Yeah.
Southern Iran. There's Greece. 5.4. Every time California goes off, Greece goes off. Crazy. March.
Does Greece normally go off beforehand or afterwards?
Just around it. I haven't really noticed one.
Yeah,
way or
it's
the other.
either right before or just after usually.
Yeah. I haven't really
Okay.
looked at how many times before versus how many times after. I haven't really looked at that. But yeah, it's interesting though, Luke. There's a Haiti 5.4, Iran, Fiji offshore 6. Woo. Eastern. Now that could be just same as the 7. What didn't we have a 7.0 just today, right? So Fiji 7.6.
Tonga,
Another
Fiji.
Japan 5. Mid-Atlantic
Small
Ridge. Couple of mid-Atlantic ridges at 6 and a 7. A foreshock of 8 seconds later.
Wow.
I don't know. What is that? Depth, just normal. Chiapas had a 6.9. Nicaragua had a 6.4. Burbank. I didn't know about that one. Actually, I remember, but it was like, hey, what happened? 5.2 in Burbank. So just east of the 6.7 in California, just east of 5.2. Fiji, Eastern Fiji again, 6.5. April, Adriana Violet 6.2, Vanuatu 6.2. Iwate offshore, small tsunamis were observed, 9 inches, 6.4. Japan. Several Bougainville, New Guineas, Indonesia, Papua, all within 6s, 6.7, yeah. Tonga, 6.3. There's a Tonga there. In May, Afghanistan earthquake, big 1994, killed 160 people. Western Sumatra, 6.1, Trinidad, Tobago. Again, what we're looking at is some activity around the Caribbean plate or Caribbean plate, whatever you want to call it. Be aware of that because we are getting quakes in the Caribbean right now. Sumatra's been banging pretty good too. These are all mid 6s.
Well, we had that big
low
one in
6s.
the Caribbean not that long ago too.
Yeah. Yeah, they called that one in Nicaragua, but it was in the Caribbean, around the Caribbean plate. Yes, 7.6, right? Something like that.
Yeah, I thought it was a 7.6.
Yeah, 7.6. Yeah. Western Sumatra, 6.5. And we're only what month we in? May. From January's, there's Crete, Greece again, 6.1. Guerrero, Mexico. The Philippines. I think Philippines popped today. Here's Myanmar. Here's Myanmar again. 6.5. So, yeah, Venezuela 6. Now you go into June. We're only 5 months away from the big quake there, right? 7.8 Java. So that's
wow.
Yeah. 6.6
That's
Java.
nothing to sneeze at.
6.5 Java. It's 6.1 Java. Bolivia's popping. Bolivia came out with a 8.2. Holy smokes.
Dang.
Yeah. I think that was a big deep quake in 1994 that they felt in Toronto.
Yeah, deep focus earthquake.
Was that the one? It was like 600 and some km deep.
Yeah,
said-
it was like super deep.
He said deep focus earthquake is recorded history tied with the 2018 Fiji earthquake. And behind the 2013 Sea of Okuska earthquake, the first earthquake from part of the South America believed to have been felt in North America, and also believed to be the largest ever recorded in general area. Due to the large depth, it was felt over a very wide area from Argentina to Canada. There were unconfirmed reports of at least 5 people killed in Peru, 3 in Cusco, structural damage in the cities of La Paz, Oruro, Cochabamba, Bolivia, Brasilia, Campo Grande, Porto Viejo, or Vallejo, Manaus, in Brazil.
See on the map, there is a 6 in Burma, Myanmar in 2018 as well. See on the map there?
Yeah, hold on here.
So same year as the big Fiji deep. It's crazy stuff. 2003,
Yes.
6.6. That's the same year as San Simeon quake.
It's
Wow.
hard when you get a bunch of these quakes together and you start wondering, in our natural human tenacity and tendency is to see patterns. That's just how we learn. We watch for patterns. But when these things happen over and again, but they're not happening like, cookie cutter, microwave time, instant, 5 minutes.
You don't get the big countdown, 3,
It's
2,
like
1,
a
and
certain
bingo.
Right.
number
You
of
don't get to
days.
see it count down to 3, 2, 1. Bang. There it is. Right.
It's a certain number of days or weeks between each one. Either, whichever one you're looking at, it's either like a little bit before or a little bit after.
Mm-hmm.
To me, it's like the plates adjusting back and forth when I look all these up. I start with the year and the date, and then I say, oh, well, that's the same year as this one. And then I look and see if the same thing happens other times. Like in this instance, we're basing everything, the data on Burma from 1980 to whatever, 2020. But I've already done 1906, 1932, 1929 to 32, 1946 we talked about last time. It went off same area. 1956 was the same time, right around was the 3 6s in Baja, and the Portuguese Bend landslide started too that same time.
Okay.
No, Canuck, you're gonna be able to see what's on you on Twitch. It's hard to show it on Rumble or on YouTube. The idea of a toroid, and the pattern of a toroid, we can see if the thing is spinning. You know what I'm saying? No, it's doing its craziness, what a toroid does. It's the ins and outs of the toroid, right?
Well, I wonder if a guy could break like these really busy years that like we're talking about, and we're seeing these patterns. If a guy could even break it down to these quakes happen on the first half of the year or the back half of the year, and kind of map it out to see if the pattern is kind of repeating on itself.
Well, the big ones.
I kind of look at it a little bit different than the time frame. Let me just throw this out there, then I'll back out. I think it's more of a dimension, not as a time dimension, but another dimension. And how to explain that, I can't quite see it, but I can kind of mentally view it, where you have the ins and outs of a toroid and how that physical toroid works. it's not time because it transcends time. It's the repetitiveness. Like if the ins and outs were always there, and the repetitive, it covers the whole entire Earth. That pattern, how a toroid works. So it could be repetitive, depending
Well,
on.
that's
to
kind
me,
of,
you
that's
have to
the
go
point I'm trying to,
global to understand what this is doing.
Yeah, you have to go global.
It's the only
well,
way
and
you-
that's the point I'm kind of driving to is
Okay.
like, if we, we can establish a pattern. Okay, A, B, and C go off in a repeated pattern, in intervals of whatever amount of time, but you see in the same year that it's a repeating pattern.
Right.
Well,
Eden. I agree with
like
you.
the
Eden.
number I've been hearing tonight is a lot of these quakes are happening on the 23rd or in March,
Mm-hmm.
especially the
Around
area
the
where we start
around the solstice
around the
Yeah.
spring equinox. Yes.
equinox. Yeah. So
And
that has to do with
there's
the way the sun and the earth's relationship happens. The
right.
the 22 degrees that the earth is at right now, and the wobble, and that's why maybe things aren't happening exactly in the same spot because of the wobble. But
Well,
over
and
time,
you're kind of making my point for me is okay, you got A, B, and C that, it goes off in the first half of the year around the spring equinox. But earthquakes happen all year. Another area may go off in a repeating pattern on the back half of the year. So, I mean,
yeah, Eden's
and
saying
if a
4
guy
quarters
mapped
of
it
the
all out,
seasons. Yeah,
yeah,
4 quarters of the 4
would it make
seasons.
more
So
sense? You could say, well, God, this pattern seems like these quakes, in the spring kind of happen along this line or this stretch, and then, in August there's another line but it's in a totally different area, but it's repeated bigger quakes.
and that quake you're talking about there has a tie to another series or sequence of quakes, just like these lineaments, right? The lineaments have their own sequence.
Exactly.
All right, and northwest to
Yep.
southeast has a series of sequence. The east to west or west to east have a sequence, and the northeast to southwest has its own sequence. And yet, when one vibrates on another, it's almost like it's a big computer creating these damn things.
Well, it's the same
Well,
as the fault. If the faults are the same thing, they have the same orientation as the lineaments. So that's how I associated.
Okay. Let's say that's true, Canuck. I'm gonna draw a map again, and you know how I'm just that's how I think out loud. Okay, here we have our Earth, right? I'm sorry, those on you got a circle on the page. You have a fault. Oh, I'm sorry. Yeah, you have a fault, right? That's on the Earth. You have the lineament along that fault. And that fault, let's say, and here's the north and south poles, right? And 22 degrees thereabouts. And the sun is here, and you get a quake, right? At this time of the year, right? And this would be in the summer, right? But on the other side of the sun, right? If it's here, you get the quake down here, right? And this is in the summer, but it's along that same lineament. Do you see what I'm driving at?
Yeah.
Well, yeah, I mean, you'd have like along that line, you'd have, let's say,
But
five
right there,
quakes,
you're saying,
you're,
there's 180 days difference, right? Now, is that part of our algorithm as well? This type of thing?
Well, obviously you're going to have obviously you're going to have the oddball quake on that liniment in a different season, but if you could
or
establish
is
a
it
line
relation?
that, okay, and
Okay,
you know, we have,
now add the idea of summer, you know, excuse me, the number of some spots. Okay, in the peak and in the valleys of the life cycle of the sun, right?
Well, I think it has to do with how it's charged.
That's what I'm getting at. The
Yeah,
charging
and it can be any time of the year, or it could be.
and then
It could
there's
be the
outside.
same liniments, or it could be different ones depending on what.
Then
it
there's
does,
outside influence from outside of our solar system
which could be different things.
during the valleys, right?
Yeah.
Right. Now, all of these give certain measure of energy, radiation is energy, right? To our planet. And depending on the position of our planet around our sun, right? Here's our sun. Here we are here today, and we're traveling around it. We get stuff from outside of it. We get stuff from the sun.
go back to that, Joe. Can you?
Say it again, bud.
Can you go back to your previous painting, or is it gone?
That's gone.
Oh shit!
I can draw that again.
I wanted to make a point, but
okay, I can draw it again. Here's the sun. Here's this one, right?
Just draw the Earth is what I'm saying.
Yeah,
there's the Earth.
To simplify, I think it's our core is responding to stuff coming in
Stimuli. Yeah.
space.
Yep.
And it can be multiple things. Now, if you're just going from the solar angle, well, it's more.
Put your big
stuff.
yellow line there again, Joe.
Yeah,
Okay,
when
but
it's solar max, it's coming more from the sun. Now, when it's solar min, it's
Right.
coming more from some other star.
From outside of our planet.
Right.
Yeah.
Because you can
But
still
I
get
guess
geomagnetic storms when it's solar min.
Right.
So you have to factor in these other things that could cause the core to respond. Like if the core wasn't doing what it was doing, the planet would blow up. So it has to like absorb the charge and redistribute it so we don't blow up.
Yep.
And I imagine the other planets probably do the same thing, whether they're a gas planet or a solid, which seems to be kind of what they're finding on Mars now, since they've had the stuff there checking it for quakes.
Right.
And stuff.
Okay,
So
but let's say, Joe, on your big yellow line
Yeah,
that you got drawn. Okay.
Go ahead, bud.
Now let's say you put 10 dots on that thing and do like 7 of them red, 2 yellow, and 1 green.
Where do you want the dots in the sun?
No, on the Earth, on that yellow line you got going.
Okay. Yeah.
Do like 7 of them red, 2 yellow and 1 green. And I Canuck, maybe this will make sense once he draws it out and I explain it a little bit.
Yeah. Well, like how I do it on my Earthquakes tracker app, which is only has 48 hours of quakes above 2.5.
All right, I drew those drawings on there for you.
I can actually see these lines all light up with just 48 hours of quakes. So what I did now, what I did when I started trying to figure all this out, I would identify those lines and see if I saw them like different times over, and then I go back historically and see if that same line lit up like over a certain amount of time.
I think what we're doing also, Canuck, is you kind of brought it to our attention, but we've already been running with it for some time, and we're extrapolating off of what you brought to us, and we've seen some patterns in different ways, but what you're doing is you're really solidifying your point of view, and we're extrapolating beyond that right now. That's kind of what's happening at the moment with what Luke is saying.
I'm just thinking out loud here too. Okay.
Mm-hmm.
And on your drawing there, Joe. Okay. Now let's not look necessarily at what specific year it is. Let's look at the
Yeah,
season.
I think. Yeah.
Okay.
Okay. Yeah. Seasons.
Is you got, like 7 of these big quakes happen in the red, which is spring. 2 of them in the yellow, which would be summer, and the green would be fall, or
Mhm.
just the opposite around. Any
Yeah.
way you want to slice
Right.
it. Is that something? I mean, I know it'd take a lot of extra input, but would it be easier to pick for us to pick out then? The repeating patterns. What's your thought?
I'm drawing
Well,
eclipses.
it's going to depend on which one you're focusing on. I don't know how to explain it, because what I find now that I'm
There
further
you go,
in this,
Eden. Eclipses.
I start identifying one that's like northwest to southeast, for example, and I say, oh, look, it's going that
Right.
way. Well, then I look the opposite way, and I find there's another one cutting through it. So then I find 2 intersecting, and then if I take it another way, like east-west, I find a bunch of quakes that are intersecting the other way. So it's like
Yep.
at least 3 lines intersecting, which I think that
Right.
has to do with a lot of these big quakes make triangles.
I was just about to say, you just see triangles in the brain. Comets and asteroids. I don't buy the idea that a comet can move the Earth. I think it's electromagnetic pulse, or the spin of it, can vibrate. Can vibrate the Earth, but not pull the Earth. Do you know what I mean? Maybe Jupiter can to some degree, but if you think of a fastball, I throw a fastball right at you. You can hear that, right? Zap, as it goes right by. But in space, there are waves, but they're not like the waves here on our planet where we have an atmosphere. There's no atmosphere out there. It's a different kind of ballpark out there. So the comet that goes through is in a vacuum almost. Yeah, unless it enters our atmosphere, correct. The particles of that, and it has to have an electromagnetic pull to affect our planet, I think. A comet, different from an asteroid, where a lot of asteroids are metal and they're not really spinning, but they have some sort of pull, and then they interact with our sun, and it's positive and negative energies and helium and hydrogen that coming out and the wave, and it's pulverizing both the comets and the asteroids and creating kind of like asteroids was the game back then, where pieces of it would, microscopic pieces would maybe come off and interact with our planet. But to change the polarity, or, maybe to cause some sort of, like, you got that ball of electricity and you put your hand on it and like the electrodes reach out to it, maybe something like that would be happening, but I don't see it changing the spin or the Earth itself. I think it interacts with the outside atmospheres, but I'm not sure how much it affects the core of our planet.
So I'm going to explain what I think about that.
Go for it,
So
bud.
it doesn't matter if you're looking at
good idea though, Eden. And I've been giving a lot of thought because of what Canuck's about to say.
Yeah. So when I've looked at all the current studies on space rocks, so it doesn't matter if it's comets, asteroid, meteorite, whatever, they say that every one of them has their own magnetic field. And what they're suggesting in the newest studies, like the last few years, is that they're somehow interacting with Earth's magnetic field. The closer they come to Earth. They interact more the closer they get to the Earth. Because there's databases, I'll give an example, of visible comets that have been seen on Earth. It's at Harvard for North America. You can actually see, and it lists like the comets when they flew over and what angle they were going. And you can actually take and match wildfires and earthquakes to the same lines, like how they were going over in the sky. So what I think is that those, if they come close enough, interact with the lineaments on the ground and cause the faults to have quakes or wildfires or whatever. That's what I think it does based upon all the stuff I've looked at so far. And when I've looked up all the asteroid impacts, which the database is actually an hour from me in Fredericton, NB, all the ones that they know about and have confirmed that are impacts, a lot of them are on these same lineament lines. And I've looked at where there's been like 3 in one spot, but supposedly they're all different times. But it's still in a straight line, like where they hit.
Kentucky, Ohio, Virginia, and West Virginia are under severe thunderstorm watch. There is another mesoscale discussion 23 minutes ago concerning it.
So I think the space rocks are actually attracted to the lineaments, and this is how this ties in. So it doesn't matter if it's a
Eastern Texas and Louisiana are in trouble. So let me look at the COD as we talk real quick. Yeah, freaking she's in trouble.
And what's interesting about all these storms, it's the same thing.
Yeah.
If you look at how the storms are, it's the same line.
I see storms very much like I see earthquakes. Earthquakes aren't the beginning of a sequence. They're the visible representation of an invisible thing that's going on. What we can't see with our eyes, we see with earthquakes. We see with storms.
And the storms are really the same thing. They're charging based upon hot, cold interaction and wind.
Positive and negative ions rising and falling on the surface. Yeah.
And I asked in a chat the other day that I was in, because it was about the storms. I said, has everybody thought to where they live, because they usually know the most about where they live, find out where the faults are in your area, and when the thunderstorms come, see if they follow the faults and check and see where the lightning strikes.
It's here, she says. It's
and I blew the people's mind in the chat because they never thought of that before.
Well, see, Eden, I think volcanoes ash gets into our atmosphere and lasts for years. The Hunga Tonga Happy Eye, I think, is affecting our planet too. So the water vapors that shoved up into the atmosphere, the ash, I mean, dude, it went 50,000 plus feet up, right? Way the hell up there. 63,000 feet, I think was it. And that shock wave went around the earth, 6 times? So, and it changed the barometers. That's how they know it was coming and going. So it's pretty crazy. Yeah, I'm looking into Susan right now.
It's weird where I live here because I know where the faults are, which I didn't know this till like just the last few years. But we've lived in this spot basically all my life. Well, when the thunderstorms come here, they either go just south of us or just north of us. Like you can look on the radar like it's coming right at us. And all of a sudden it jumps either to the south or north of where we are. And it's exactly where the faults are. And my aunt used to live right next to the fault line, and she'd get lightning strikes all the time in the summer. Because I think the storms were jumping to those faults that were charged.
Yeah, she's got it right in there with you. Right in there with you, sis.
I've talked to other people about this, and then they've started looking. And then they said, oh, well, that's interesting. Because I think all this stuff is all related.
Hopefully it clears up real quick. I know you're north of the road, so yeah, you're right. You're right in the midst of it.
And tornadoes always seem to move northeast. which is the same orientation of the faults in the Dixie Alley, and it's pretty interesting stuff. So
This sucker,
I didn't
these
know
things.
that all this stuff was late when I started, but then I said,
Like what? I mean, we're watching. Share this in tab. Okay, this is what I'm watching. I'm watching Western Tennessee right now, where his sister is. She's got these series of storms. I'm always intrigued at how come this little thing right there as it's coming down, it kind of starts everything and it keeps pulsing, and all the storms are coming out of that little tiny something. You know, it's very, very weird. I don't know what that's called. 9
well, and
alerts.
how the tornadoes are, it's always a little bit ahead of the main line, the worst tornadoes.
Yeah.
So like whatever they call it, the dry line or whatever.
Yeah. It just passed through her. It's by the Mississippi conjunction. Yeah. It's south.
And you can
of
almost
now,
see it like light up when it goes over where the lineaments are, and then it calms down a little bit, and then when it gets to the next one, it like re-intensifies again. I've seen it do it in Oklahoma and Texas like a bazillion times on the Nemaha Ridge.
Right.
And then it does it as it comes farther east too, and it goes right up.
Sis, get the shelter.
Grid and all that stuff. It's crazy.
Do you have a shelter at your house, sister? You know, you probably need to be in a shelter because these things are right over you, no doubt.
And it kind of does the same thing on the East Coast when you get severe weather. Doesn't matter where it is. And it always seems to be in a northeast to southwest thing.
Right. Seems like the storms across the U.S. do that, except for when they're in the West.
Yeah, because your faults are the majority of the faults on the West Coast.
Northwest to southeast. Yes.
Yeah, that's back of the woods. They come from the northwest.
Yeah.
Now
there are lineaments that go the opposite way that cross the West Coast, but
I think she's like right up in here. It's right over her right now. She, we're watching you too, Timmy. I know you'll be in about an hour, 2 hours.
Because now they talk about the Schumann resonance has a lot to do with thunderstorms too. If there's a lot of thunderstorms, the Schumann is
right. Talking about the Schumann resonance. It's not this one. Is it this one? No, it's this one. All right. Let me close these. Open this. Share this tab instead. These are the proton flux that's upon the density upon our planet right now. I push play. You can see how it buffets against our magnetosphere. Comes in waves, right? This is computer generated, of course. What the hell is she doing now? Throwing something away. And you can see that it's just non-existent, right? Here's the pressure upon our planet, pushed upon our magnetosphere from the sun. The sun's off to the left, right? The equatorial region looking at it versus up at the North Pole looking straight down, right? And you can see this area right here, we're not seeing this being buffeted at all. So the Earth is relatively quiet. You'd see a little back pressure when it comes back. There's a big bubble out front. There's another one, kind of a tail, when the L shells get peeled back. And watching this video as well. And I think the Schumann resonance has this to play. Watch back here. See that? Boof. Right? See these waves come back? Watch that blue area. Right? And you'll see a boing. is because you can get a CME on the front side from the sun. Also, it'll come back on the backside because it goes around the planet, gets sucked in to Schumann resonance. That's what I think is going on there. But hey, just my 2 cents.
Well, you can get other things from the backside too when it comes to cosmic rays coming from somewhere else.
Sure. Yeah.
So it's pretty interesting.
You just got to have no solar wind. If there's no solar wind, the cosmic rays come into it. And that's what we're doing. And I was talking about on our drawing right there, right? Okay. Outside the blue line. Usually happens in the solar minimum. And believe it or not, a lot more bigger quakes happen at solar minimum than solar maximum. But hey, that's just an observation. Anyway, shoot, how long have we been doing this here?
Yeah,
we're an hour and 30 in. Did you get what you wanted to get in there?
Yeah, I mean, they wanted to do 1839 in this study, just to give you examples. Like I have way more. I could have done 1906. I could have done 1932. I could have done all the quakes in Burma from 29 to 32 because they started with big ones at the bottom and came right up.
Right. We could have done the Denali and all that stuff too. And all the like. And take a quick look at what's going on. It's like Bel Air just got rocked with a little earthquake in Southern Cal. Little one. Sierra Madre Mountains, Parkfield. Well, that's interesting. Do I have it over here? No, I don't have it there. No, I don't have it.
Well, what I found, just to summarize, for the West Coast.
Go ahead.
Which is everything from Jalisco, Colima, all the way up to Haida Gwaii, Vancouver Island. When Burma gets a 7, you get bigger ones in between those spots.
That's Southern Cal getting an earthquake right now.
Yeah. So we'll see what it is when it comes up.
So, well, I had fun tonight. Is there anything else you'd like to say, Luke?
No, I'm good. I learned a lot again tonight.
Yeah. You had some really good insight onto what you were trying to say. I thought I could add to it and kind of mix it in a little bit.
Yeah, so it was good. So we covered even more stuff. Yeah.
Yeah, I mean, there's so much to this.
Before, we just went into more detail, I think.
Right. There's so much more to this. And I think the more we do this, the more we're able to articulate things a little bit better and perceive some of these articles in different ways that are kind of proving our point,
Right. And we can also do a part C and a part D and an E on this too.
It's never ending.
Yeah, because 1906, so that was the stuff happening around the same time as the San Fran big quake.
All right. Well, we're not going to get into the pyramids tonight. I wanted to, but we're not going to get into it.
I think the pyramids are on the same lineament lines.
That's okay. We'll get there. Hold on. Part 2 with the pyramids going to be Wednesday. All right.
Part B, pyramids.
Yeah. And the new stuff, I'll give a tease because it's just one liner. Some of the stuff is suggesting now that it could be the Pillars of Enoch. All the pyramids. And that's the tease for now, so everybody can go look that up. The Pillars of Enoch.
That's a good one.
Yeah.
I use the Tower of Babel. That's what I think it was. But hey, that's me.
Well, they're not sure if this is based on the Tower of Babel or it's actually based on the new city of Jerusalem that's supposed to come down. And that's what the Pillars of Enoch are, a smaller version.
Oh, yeah. Everybody's an alien.
So when you start looking at Pillars of Enoch, it'll open
It's a spaceship coming from Mars. Ah!
I have a theory about when the new Jerusalem comes down, what's going to happen too.
All right, cool.
But
We'll talk
come
about that when
It's a theory
next,
I have.
when
Fun with
next
people say.
Wednesday, everybody. So come back and see us talk about the dang. Everybody seems to have an opinion at it. I want to dig into it and find out what other knuckleheads are talking about these. Ooh, I just got a notice on my phone.
Hey.
On my phone today. Get this. I haven't read the article.
Oh, it gets into cool stuff about the Ark of the Covenant too and what it does.
I know. God bless America.
Good stuff.
An engineer says he found a way to overcome Earth's gravity. Oh, and it's a picture of a toroid. 3,200-year-old Egyptian tomb of Ramses III, military commander, uncovered. Yeah. Crazy, huh?
Yeah, definitely.
Oumuamua asteroid just entered the solar system, but we're not alone.
Coming back around again.
Yep.
I thought it went through before. So it must be coming back around.
This might be kind of bullshit. U.S. government confirms payment of up to $1,450 to millions of Americans by April 1. What happened to the $5,000, man? Why is it only $1,450?
McDermott Caldera is worth $1.5 trillion in lithium right now. It's the new thing I just saw.
I don't even know where that is, dude. Oh, that's in Nevada, right?
I thought the McDermott Caldera is one of the Yellowstone blow-throughs, isn't it?
I thought it was in Nevada, right? Northern Nevada. I don't know.
I thought McDermott.
I don't know.
Yellowstone blow-throughs.
23,000-year-old footprints discovered in New Mexico. Human history in North America.
Now I got to look it up because I'm pretty sure McDermott is one of the Yellowstone.
Somebody bought a Vincent Van Gogh painting worth $15 million for $50 at a garage sale in Minnesota.
No way. Ain't that crazy?
Ruled not authentic. You're right. Okay, let me burn it. No.
Yeah, McDermott Caldera is a large oval-shaped caldera west of McDermott in southeastern Oregon and runs into northern Nevada, so it overlaps.
Okay. Yeah.
And I'm pretty sure it's one of the Yellowstone blow-throughs. And now they found out it's got 1.5 trillion worth of lithium in it. That's the thing that came up in my news stuff here right before we started tonight.
That's crazy.
Yeah.
That's a lot of lithium.
Yeah, Lithium Valley Holdings Corp owns it, which owns the McDermott lithium property.
Huh.
Which they thought there was a lot there, but not this much. So now it's way bigger than what they thought. So now they're probably going to go around looking at all the calderas now to see what. Every friggin' caldera has probably got lithium.
What does that tell you? Where does a caldera come from? Right? The upwelling of magma, right? The creation of that stuff. So a caldera is a dead volcano, right? When a volcano collapses, that's what a caldera is.
They say there's a whole bunch of lithium in Salton Sea too. So what does that mean? Was that a gigantic caldera?
Go out and buy a volcano. That's what it means.
and here's your last burner for this video on Rumble and on YouTube and on Twitch. Trump tells NBC there are methods for seeking a third term. Good night, everybody. Love you. Have fun. Get ready for the next week. Love you. Bye.